Is it on? You're right. Yep. Cool. So yeah, I'm Sebastian. Is that contrast really bad? Can you read that? Do I need to change the contrast? Good. Yeah, so I work at Canva. I'm a mobile developer in the mobile platform team. You can find some of my previous talks, and I will upload this talk to GitHub. If you have any questions that I can't answer today, my DMs are open on Twitter. I don't really tweet, but feel free to reach out to me if you have any questions. Just a few things to start off with. The talk on Combine. Combine is obviously still beta, but I don't think there's going to be many changes because the final release will be out in like a week or two. The API is huge. It's really, really massive. There's like hundreds of types and functions in there. There's a protocol publisher that I'll talk about later. There's 89 implementations that I counted. There might be more. So I can really only scratch the surface here. I think I've got 25 minutes, so we'll see what we get to. So what is asynchrony? So an asynchronous operation is an operation that doesn't block the thread of execution. What does it mean? What does it look like? An obvious example would be a network request. We request something. A while later, we get something back. But our UIs are also asynchronous. We create a button. We put it on the screen. Sometime later, the user taps the button, and we get notified about that. Maybe the user changes the content of a text field. There's many events that all come in asynchronously, and often we're interested in how those things change. But even animations can be seen as a asynchronous operation. So what's the issue? It's really hard. I find programming really hard. Maybe you don't find it hard, but I find it really hard, and then you get to asynchronous, and it gets even harder because your program flow is no longer linear. Things just don't become predictable because you say, like, there's two things happening, and then they might come in different orders. And then maybe we'd need to deal with synchronization. The other problem is there's often very different patterns that we can use for asynchronous operations. There might be target action, which we've dealt with for a long time, especially in UIKit. There's delegation. Sometimes something might request some other stuff later on. And then we get notified about one change, and then we need to go and read mutable state from somewhere else. And recently, a lot of those APIs moved to callback-based patterns. But there's so many different things which make it even harder. And so you end up with like these long indentations in nested callbacks, so you might have to move your functionality into different functions. And when you read the code, you have to jump around a lot. I find that really hard to read. It's also really complex to abstract that because while you've got different patterns, you need to deal with things in a slightly different way. It leads to a lot of repeated code, lots of boilerplate code. Again, I find this really hard to read because I look at things and all the information, all the important stuff that I care about is hidden in between all this noise of like having to deal with things the same way all over again. And those imperative patterns, they lead to mutation all over the place. So often I'm setting the same state in a few different places, or read the same state in a few different places. And it's hard to keep track of where that state is read and written, and whether I need to query state changes from somewhere else, or if I'm actually notified about it. Something as simple as enabling a sign-up button only when the user has entered a valid email, has entered a strong enough password, and both the password verification and the password field are the same. You need to observe several notifications. Then when a notification comes in, you need to read the other mutable state. And then maybe you need to mutate the button in several different places. And the best that I could come up with looks something like this. I mean, it's not terrible. I don't really find that readable. And once the requirements change, if I have to add to that, it gets so much more complex. And then we have to deal with things like we might have two parallel operations, and we need to wait until both of them are finished. Or maybe we want to get a network, perform a network request, but it might also be cached. So we might start both requests at the same time and just take whatever comes back first. We might want to handle timeouts, or we do a lot of requests when the user types something, so we want to handle debouncing. There's error handling. And then at some point, maybe the user leaves the view controller that that contains all that logic, swipes back, and we need to make sure everything's cancelled as well. I find this really hard. So now Apple came up with something completely new. Well, no, they did not. All of these concepts are actually quite old. So in Objective-C, we've had Reactive Cocoa, which was open sourced by GitHub in 2012. And now that's ReactiveSwift. And we also have RxSwift. And both of them go back to Microsoft's Reactive extensions, released in 2009. And most of these ideas are based on a paper that was released in 1997. But it feels really at home in Swift. Like, we've got the type system, the way that Swift is structured, and obviously Apple also added a lot of good features to make to Swift to make this really really enjoyable. So when we talk about reactive programming, two terms come up a lot, and that's imperative versus declarative programming. So what do we mean by that? Imperative would be you specify some steps, a list of steps, how to get to a solution, whereas declarative would just be describing what that solution looks like. You might be thinking, well, if I'm programming, I have to tell the computer what to do. I have to list the steps, but that's not quite what you need to do. Whereas if you look at this example where you have a for loop, you have an array of numbers, and you're interested in the square of those numbers. In Objective-C, we would create a new variable that holds that array, and then iterate over all the numbers, square them, and append them. This is like a list of steps on how to get to the result. Whereas now in Swift, we can just say the result is the numbers squared. And this is actually declarative. I'm telling the compiler what the result is. I don't care how those numbers are calculated, whether there's iteration. It's not my concern. I'll let the compiler figure that one out. And so combine lets us write asynchronous code declaratively. The main two types in combine are publisher and subscriber. So a publisher delivers a sequence of values over time, and a subscriber acts on elements as it receives them. So you can imagine them sitting at two different ends of a pipeline, whereas your publisher sends values, and your subscriber acts on them. And then in between, we can use combine to manipulate those values and maybe start more asynchronous work, and then build this pipeline where we get to the subscriber who can then act on these elements. The publisher in SwiftUI is a protocol. It's a very small protocol, as you can see here. It's got two associated types. Output, so we know what kind of values the publisher will send, and failure, so we know if anything goes wrong, this is the type of failure we get. This is a bit different than things like throws in Swift, where we don't actually know the exact type of the error. In combine, we usually know the exact type of the error. And there's only one function in the protocol, which is receive. So when you have a publisher, you can just pass a subscriber in, and then the two will establish a connection and then start sending values. So what does an asynchronous call look like? If you traditionally have a function that takes some kind of value and a callback that eventually gives you a result, now you have a function that gives you that you give a value, and it returns a publisher that's generic over the output and the failure. And it will be some concrete type. But most of the time, you don't need to care about what type of publisher is being returned. If you have an asynchronous function that you know cannot error, you can denote that by returning a publisher that has the error case, the error type set to never. And because never can't be created, it's guaranteed that this publisher will never fail. Apple provides a lot of APIs, combine APIs for their asynchronous APIs. So for example, URLSession, you can get a publisher for a data task. You can get a publisher for a timer. You can get a publisher from Notification Center, from KVO. And SwiftUI makes heavy use of combine to drive the data flow. So most of the time, we don't really, we can do a lot with combine without explicitly creating a publisher. We don't have to implement the protocol. Most of the time, we can use something that we get back from some API. So for example, we can create a publisher from a timer that publishes the current date, that sends the current date every second. We need to specify the run loop and the mode, but they're not really relevant here. And now if we want to observe that or subscribe to it, we don't really have to create a subscriber. We can use the function called sync. And this is really similar to the callback-based approach. Sync takes a function that every time the publisher sends a value, the function gets executed. So we can now print the current date every second. If you actually run this, you'll notice that nothing actually happens. That's because, and this might be surprising if you use the other Reactive frameworks, some publishers need to be explicitly connected. So a publisher for a timer actually doesn't send values until you connect it. But you can call autoconnect, and then everything is taken care of once you attach a subscriber to it. Now this is still not very declarative. I'm still just like doing something and printing something. To make this more declarative, you can subscribe to it in a different way. And this is the assign function, which takes a key path and an object. And every time the publisher sends a value, it sets the value on that key path on that object. So now you might have a current time property, and you know that every second this is being updated. There's a few functions that will look very familiar to Swift developers. If you do use Swift, you will be familiar with map on optional and array. There's also map on publisher, and it works pretty much exactly the same. It takes a function that you can transform values. So for example, now I've got a label, and I want to set that text to the current time every second. I can use map to create a string from that date, and then assign it to the label. You might also be familiar with filter. And again, it works exactly the same way. Filter takes a predicate function and only forwards values for which the predicate is true. One thing to note here is that those functions, in the same way that map and filter don't modify arrays, but return new arrays, we don't modify those publishers. They just return new publishers. There's one more thing that I omitted, because if you do run this code, again, it will not do anything. Luckily, there's actually a warning. So when you try to compile this code, you'll get a warning. Result of call to assign is unused. You'll get the same with sync. And if you look at what is actually returned, they both return an any cancelable. Cancellables are a combined way of handling cleanup once something's not needed anymore. And with cancellables, you can make sure that a whole pipeline is cleaned up after you're not interested in the results anymore. So we do get the warning, but sometimes we really want to know what is going on. Like sometimes something might not work properly, and you want to debug this. Debugging can be really hard in reactive programming, but luckily, Apple provides a function called print. So you can call print on any publisher, and then once you connect it, it prints to the console all the interesting events that will happen. So for example, in this case, we receive a subscription. There's something about a request that I'll get to later, and then we receive cancel. So this chain is automatically canceled straight after we create it. And the reason is that cancellables in Combine, they cancel the activity straight when they're deinitialized. So you have to keep a reference to the cancelable. Let's have a look at the protocol. Another really small protocol. The only thing that you can do with a cancelable is cancel it, which is also automatically done on dinit. You may want to do that if you, for example, you start some long-running task, and then if you just hold a reference in your view controller and it's deinitialized, it will automatically be taken care of. But sometimes you might want to manually cancel an activity. There's two ways to keep a reference to them. The obvious one is just declare it in your view controller and be done with it. The other one, this is really useful if you want to hold on to a specific one, but sometimes you have a lot of subscriptions and a lot of pipelines to deal with. In this case, you can use the the store function and just give it a reference to a set. And that way, you just have one set of cancellables. And at the once your view controller or whatever class deals with that is deinitialized, everything in the set will be deinitialized, which means the activity will be canceled. And so now the output from print actually looks like this. We get values. So what is this request unlimited? In combined, subscribers control how many items they receive, which is very different to the existing frameworks on iOS or in Swift, where a publisher or whatever they're called there just send as many values as they want. Sometimes you might find that a subscriber can only handle a certain amount of values at a time. So the subscriber tells the publisher how much demand it has for values. So let's have a quick look at the subscriber protocol to see how that all works. Just like the publisher, a subscriber has not an output, but an input, which corresponds to the output on a publisher, and a failure. So if you've got a publisher and a subscriber where those two types match up, you can connect them. And the three functions are: a subscriber can receive a subscription. Get to that in more detail in a minute. But a subscription is essentially a way to communicate between a publisher and a subscriber. And then once the publisher receives a subscriber, it can use the other two receive methods to send values or send completion. And the important thing to note here is that once a subscriber receives completion or a publisher sends completion, it's guaranteed by the Apple publishers. And if you implement your own, you should not send any more values after sending completion. Which means, if anything, if a publisher sends a failure, it will not send any more values. This becomes really important once you put these publishers in a longer chain. What does that subscription look like? The only thing you can do with a subscription is request items through it by just specifying a demand. And a demand cannot be, it's an opaque struct, but it's essentially just you can request an unlimited amount, you can request nothing, or you can request up to a certain amount. Publishers, and if you implement your own, you have to guarantee that they do not send more values than requested. And Apple's publishers do guarantee that. So the life cycle of this looks something like this. You've got a publisher, you create a publisher, it receives a subscriber. The publisher creates a subscription, passes that to the subscriber. So now they've established a connection. The subscriber uses that subscription to indicate demand. The publisher starts sending values. Maybe it doesn't send any values. Maybe it sends lots of values, never more than the demand. Every time it sends a value to the subscriber can return a different demand, whether it wants to get more values. And then eventually, the publisher sends a completion event. And all of this can be canceled. You hold on to the cancelable. You can cancel it at any time. One thing that I struggled with when I first learned about all these concepts was handling state. Why would you want to handle state? You might want to accumulate values from a publisher that sends many values, or maybe you want to compare new values against an old value to make sure that if the same value is sent again, maybe you don't want to forward anything. You might be tempted, and this is actually what I did, to do something like this, but please don't do that. So you could create some state outside of your publisher, and then use map to modify the state. And so read the state, modify it, and return something else. This works fine in a simple example, but once it gets more complex, for example, if you share the publisher, this will have really weird results. For example, if you subscribe twice to the publisher, it actually adds 2 every time. So you don't get 2 separate counters. You get one counter. You get 2 counters with shared state. So what you want to do is you want to use scan. And if you've used reduce on erase, you essentially know what scan does. So just as a reminder, you can use reduce with an accumulator. So you give it an initial state, and then it goes through all the elements. And for example, you can use that to sum up the numbers in an array. scanned as exactly the same. So for example, if I want to create a counter, I can start with a 0. I'm not interested in a date, so I'm ignoring that argument. And every time I send a value, I increase that counter by 1. And now the state is local to my publisher. And this is really important. If you do have state, make sure your publisher owns the state. It doesn't leak anywhere. If you do need to depend on external state, it should also come in through a publisher. If you don't do that, unexpected things will happen. So if we start consuming a publisher from a URL session, we note something interesting. We can get a publisher just from a data task. Given a URL, we get a publisher. Once we subscribe to that, it will fetch something from the web. Sync and assign are not available in this. And the reason is that in this case, the error case is not never. So as any other network request, something can go wrong. So we'll actually get a URL error back here. So you can use sync with a receive completion and receive value. The completion can either be success or failure, where you get the error. But sometimes you do want to use, you want to modify that error because you want to handle that error in a different way. Sometimes you just want to discard the error, and you don't care about the error, and it's fine if it just completes. Error handling in Combine is done with catch. If a publisher sends an error, then catch will actually get that error. In this case, I don't care about the error, and I'm returning an empty publisher. So catch always returns some kind of publisher. It has to return the same output type, but you can change the error type. So in this case, I'm just discarding the error. If the original publisher errors, I just complete. But sometimes you are interested in the error, or maybe just in the fact that an error occurred, but you still want a publisher that guarantees that there's no error. For example, if you use a publisher in a long pipeline that can error, then it will not send any more values. So if you return that error from that publisher from somewhere, you might want to receive a completed event instead and handle the error in the value. You do this by mapping the values, in this case, into an optional. You probably want to use some more descriptive type. And then you send nil in the case of an error. The last thing I want to talk about is how to combine publishers. And this ties in a bit to the example that I showed at the start of the talk. So say you've got a password publisher and a password confirmation publisher. You can use combine latest, which gives you a publisher that once one of them sends a value, it will send you the latest value of both of them. This obviously only works once both of them have sent at least one value. And so with this knowledge, we can now build this pipeline where we can say we've got a password and a password confirmation. We create a bool publisher out of this by mapping it to equals. We combine this with the email, and there's a typo there. The other one should be password.map. So we make sure that the email is valid, the password is strong enough, and then we get a tuple of 3 bools, and we just use and to make sure all of these conditions need to be true. And we assign that to the isEnabled property on button. So anything that I add in here now reads almost linearly, unlike the asynchronous code that we had before, where I might have to jump around, have different functions. When I made these slides, I thought it might be really useful to show you what types those publisher chains return. But then I actually looked at the types, and they looked something like this, which I don't think you can read from the first row. They do look something like this, which is still not really readable. Can anyone tell me what type of value will be sent? I couldn't, because who knows? This can be really hard, and sometimes it can lead to weird compiler messages because the types are just massive. If you're ever in a situation where you inspect the type and it's something you can definitely not read, there's a function for that. It's eraseToAny publisher. And eraseToAny publisher always returns an any publisher. And in this case, this long thing actually just sends bools and no errors. So we can use eraseToAny publisher to make sure that we can read our types. And sometimes you might want to store a publisher And then you'd also have to erase it because you can't store the protocol because it's got associated types. And you might not want to depend on a concrete type of publisher, because if you use a map, you'll get a map publisher back. If you use a filter, you get a filter publisher back. You just erase it to any publisher, and then you've got something you can actually store. So some tips to get you started. I would start using it in isolation. So for example, just make your network requests use combine. And then maybe you use map because you want something slightly different back. Maybe you want to extract something. You want to pass the JSON. And then once you do this, start combining publishers. This is really powerful, where you have like two things that are happening at the same time. Combine them, and most of the complex stuff will be taken care of for you. I'd go and use assign. Just make your code more declarative. This is really powerful. Once you know how to use this and use assign, you can write much more readable code. But be aware that don't assign to the same key path in multiple places. You lose a lot of the advantages. You only want to mutate, so use assign only in one place. And that way you get that declarative advantage. One thing that you should avoid is going back and forth between imperative and declarative. Isolate one part of your code base, make sure it works well, and then leave the rest in the imperative way, so you only have one bridge. If you go back and forth, it gets very confusing easily. This is a question that's been asked here quite a few times. Should I use this in production? Yeah, if you're using SwiftUI, you are essentially forced to. SwiftUI uses combine. But be aware that if you don't use SwiftUI, you still have the limited targets for combine. It only runs on the latest iOS and macOS. It's not open source, so it doesn't run on Linux. If you run into issues, you might not find documentation. If you use some of the existing frameworks, you will find the documentation. They're very mature. Combine is you will still be an early adopter. But having said that, I believe that combine will likely be the standard for reactive programming on Apple platforms very soon. I've got some further resources. Just if you're interested to dig a bit deeper, definitely look at the documentation for combine. There's two WWDC videos from this year, 721 and 722. There's a really good reference book on GitHub that's free. I'd encourage you to look through that. There's a few examples, almost like recipes, what you can use. Someone's making an open source implementation of combine. This might be really good if you want to use combine in iOS 12. It's not finished yet, but it looks really interesting. And if you're interested in some of the underlying ideas, maybe look at the last two links. And if you're really interested, learn Haskell. It really taught me a lot about Swift, even though I don't use it in production. I've learned a lot about reactive programming in general just by reading this book. Thank you.